between between Cartesian coordinates and polar coordinates is here, where keep in mind that the stresses here are the effective stresses, right? Sigma is S minus pi, right? Where this is the tectonic stresses minus the pi, and delta p is just what it was before. So it's the difference between the mud weight and the pore pressure. I guess just to be consistent, this is also the pore pressure, right? So, and nu is Poisson's ratio. Okay. And these are in the simplified form of, being at the wellbore wall. So it's not, there's no R in here, it's not taking that into consideration. So these are, so again, the step is you're given the tectonic stresses in whatever orientation they're in. You rotate them into the geographic frame. You rotate them from the geographic frame into the wellbore. You convert them from Cartesian to polar coordinates. Okay? Now, unlike when you have a perfectly vertical well, in a perfectly vertical well, the principal stresses are always sigma theta theta, sigma RR, and sigma ZZ. In an arbitrarily deviated well, you can't make that same statement. Okay? One of the principal stresses is still sigma RR, right? And sigma RR is equal to delta P at the wellbore wall. Right? So one of the principal stresses is still sigma RR. The other two principal stresses are the minimum and maximum tangential stresses, and they just have to be resolved. Right? And the equations that resolve them are these. Okay? So that gives you the minimum and maximum tangential stresses from the polar wellbore coordinate stresses. Right? So now we have enough information to solve problems of wellbore failure, wellbore stability in arbitrarily deviated wells. And again, I just want to repeat it so you can memorize it. Right? The steps are, given the arbitrary principal stresses due to tectonic stresses, you rotate them into the geographic frame. From the geographic frame, you rotate them into the wellbore. Then you convert them to from Cartesian coordinates to polar coordinates. Then from polar coordinates, you determine the minimum maximum tangential stresses. All right? That's two of the principal stresses. What's the third one? Delta P or sigma RR, okay, at the wellbore wall. So now you have the three principal stresses. You can order them, greatest to smallest, and now you have a Mohr circle, right? You have a Mohr circle. The Mohr circle is defined by the greatest and the smallest, right? Sigma 1 and sigma 3. That and the material properties and that kind of stuff. And you can determine if you're going to experience wellbore failure.